In the previous example, we integrated a fraction where the degree of the numerator was less than the degree of the denominator. Such a rational function is called a proper rational function. Sometimes it may happen that the degree of the polynomial in the numerator is equal or greater than the degree of the polynomial in the denominator. And then we can use a simple trick called division of polynomials to convert such a function into sum of polynomial and a proper rational function. So let me remind you how we divide numbers. If we divide, say, 100 divided by 7, elementary school, right? Then we take the beginning, 10 divided by 7 is roughly 1. But not exactly, there is something more. So if we multiply 1 times 7 and we subtract from 10, we get 3. We copy this digit and we divide once again. 30 divided by 7 is 4. Approximately, not exactly. 4 times 7 is 28. We change the sign, we add, and the remainder is 2. So we can write it as 14 plus the remainder 2 divided by 7. And we can do the same with polynomials. If we write x cubed plus x squared minus x plus 5 divided by x squared plus 2x minus 3, we can proceed in a similar way. X cubed divided by x squared is x. But not exactly. We should correct this. Similarly, as we multiplied 1 times 7 is 7, then we multiply x times this, and we write it here. X times x squared is x cubed plus 2x squared minus 3x. Then we change the sign and we add these two terms. X cubed minus x cubed is 0, that's good. X squared minus 2x squared is minus x squared. Minus x plus 3x is plus 2x plus 5. And then we divide once again. Minus x squared divided by x squared is minus 1. But not exactly, we must correct this. And we multiply this by this. Minus 1 times x squared is minus x squared, minus 2x plus 3. We change the sign and we add. And we have minus x squared plus x squared is 0. 2x plus 2x is 4x. And then 5 minus 3 is 2. And this is a polynomial of order lower than this one, so no result. This is remainder, and we write that the remainder is 4x plus 2 divided by x squared plus 2x minus 3. So this was the improper rational function, and we can write this as a sum of polynomial and a proper rational function where the degree of the polynomial in the numerator equal to 1 is less than the degree of the polynomial in the denominator equal to 2. Well, and we know how to integrate polynomial, not a problem, and from the previous section we know how to integrate a proper rational function.